moving on. Again, remember this section just is taking everything you learned and kind of shoved it together. So I did ask myself a question on this one. Can I make it simpler? Is there a number that goes into all of those? For a minute there, I was thinking 3 did, but 3 does not go into 49. Then I might decide to give it a test. Is this a perfect square? Yep. Is this a perfect square? Yep. Well, now I'll run it through this test. Is 42 2 times the square root of 49 times the square root of 36? So is that 2 times 7 times 6? Oh, by no means. 7 times 6 is 42, but when I double that, it doesn't stay 42. That means doing this little thing up here would not work. Okay, my next step is to go back to what I know, and I will have to do an ACB chart. I need to confirm how we can simplify this. This is a gross problem. 49 times 36, A times C, is 1764 that has a product, a sum of 42. Well, we would start with 1 times 1764. No way. We could go with 2 with 82. Then we could test 3. We could test 4 and so forth. I will help you on this one. It is prime. But because it didn't work here, I cannot jump to that conclusion. I need to go to my toolbox and try something else we know. But for time's sake, I would just let you know it is a prime situation there. Okay. Wow. Look at a blast from the past. There is many ways we could approach this one. A is 1. So we could go to this. Whenever A is 1, I need numbers that add to 8 but multiply to 16. Remember those days? Well, positive 4 and positive 4 add to 8, multiply to 16, so I could have x plus 4 times x plus 4. Ooh, that looks familiar. I could have said, okay, I see a trinomial. I can't make it simpler. Is this a perfect square? Ooh, yeah, it is. 1 is a perfect square. Is this a perfect square? 16 is. Is 8 2 times the square root of 1 times the square root of 16? 2 times 1 times 4. Oh, it sure is. I could have factored that using the perfect square trinomial. I would take the square root of the A term, the square root of the C term, and the sign that's in front of B, way over here, would go here and square it. Again, perfect square trinomials is just another way to solve problems I taught you how to solve earlier. Let's look at this one. What is the first question you're asking yourself out loud? Hopefully you wonder if I can make it simpler. Is there a greatest common factor between 4, 12, and 9? Not that I can think of. You can, if you want, ask, is that a perfect square? Yes. Is this a perfect square? Yes. Is 12 2 times the square root of 4 times the square root of 9? 2 times 2 times 3. It is. Great. If you want to memorize how to do this, fine. I am not a fan of shortcuts because I tend to forget one little thing. So square root of the A term, leave me with 2x. Square root of the C term, 3. And I need the sign in front of B. And that would be squared. Okay, again, you can go to your wheelhouse. What do you really know? We've practiced this quite a bit, so I could go back to my ACB chart. I would need factors of 4 and 9, which make 36, that add to 12. Well, 36 is not a big number. We can come up with those relatively fast. I would have 1 and 36. They add to 37. 2 and 18, we're getting closer. We have 3 and 12, getting closer. This is a sum of 15. We have 4 and 9, that's 13. Oh, there it is, 6 and 6. So 4x squared, I started my grouping, plus 6x plus 6x plus 9. Remember, this is my A term. These two together make the B term, and that is my C term. So step 1 of the 3 is we need to group. Step 2, greatest common factor. The steps don't change. I could take a 2x out, leaving me with 2x plus 3. Ooh, I could take a 3 out of this one, leaving with a 2x plus 3. Wow, I'm excited. Highlighter time. I have a set of identicals. Oops, ran out of room, but oh well. Combine my greatest common factor. Put one set of my identical. And oh, these binomials are exactly the same. So I have 2x plus 3 squared and 2x plus 3 squared.